In the name of Almighty Allah, the most merciful and the most beneficent, a very, very warm welcome in this first session of Physics, Week 1. I am Habibur Rahman. Welcome you all in this bright session. I hope you will enjoy this session. Today we will start our new chapter, that is our first chapter of Physics, Class 9, the physical quantities and measurement. In this chapter, the major concepts which we will discuss are Introduction to Physics, Physical Quantities, International System of Units, Prefixes, Scientific Notation, Measuring Instruments which includes meter rule, vernier caliper, screw gauge, physical balance, stopwatch, measuring cylinder, and stuff like that. And in the end, we will discuss about the significant figures. These are the major concepts which we will discuss in this Unit 1. But in this session, we will just focus on three main topics, that is about physics and its types, and the third one is physical quantities. The main objective of this session is that you people will become able to describe physics, then you will be able to describe its types, and then you people will be able to describe the physical quantities in detail. These are our major topics which we are going to discuss in this session. First of all, we will take a quick and brief and a comprehensive review about the introduction of physics. We will discuss that what is the role of physics in our daily life, why physics is important in our daily life. Then we will discuss about the branches of physics, and in the end we will discuss the physical quantities and its types. First of all, it is compulsory for every student, for every physics student, to know about the importance of physics. That why is physics important? Why he or she is going to study physics? Some of the possible answers of this question are given in this session. In this slide you can see. Firstly, physics is fundamental. Physics is the base of many sciences. That is why principles of physics are used in many other sciences. And the second possible answer for this question is physics teaches us to investigate. Physics helps us appreciate our universe. Physics is the basis for much of technology. So you see, physics in every part, if you see any application, any electrical application, electronic device, any other technology, you will see that physics is directly or indirectly involved in such type of technologies which are currently active in our world. Now, from where this word physics originated? It originated from Greek. In Greek, or the word physis means nature. This word physics is basically originated from this Greece. This physics is originated from Greece. Greece is basically, you can see from the map, is here in Europe. In Greece, the word was physis, means nature. So from this word it originated. This means physics is basically a knowledge which we are gaining with the help of observations and experimentations. And this knowledge is totally deals with non-living things. And it's not a new subject. Physics is not a new subject. The purpose of this slide is I want to show you people that physics is not a new subject. It is a very old subject. Basically, in the start, maths was the basic subject. And from maths, physics, most of the concepts in physics and most of the topics in physics has the basis from maths. And then on the basis of physics, other sciences originated, like chemistry, astronomy, and such type of things, such type of subjects. Now, very brief definition is in front of you people. You can see the first definition is physics is the study of various physical phenomena and the fundamental laws governing them. And if you want to learn the definition in a very precise and in a very brief way, in a very easy way, then the second definition is more appropriate for you people. That is the study of matter, energy, and their mutual relationship is called physics. If you see this definition, you can see that there are three words in this. First one, matter. Second one, energy. And the mutual relationship between these two. Matter includes all the substances which occupy space and have some mass. All those substances will be called as matter. And energy includes your kinetic energy, mechanical energy, your heat energy, wind energy. Lot of types of energies are present today over which different researches are going on. So the relationship between matter and energy and the study of matter and energy, all this stuff is included in physics. All the stuff which is related to and relevant to the matter, relevant to the energy, and relevant to their mutual relationship will be included in physics. So when we will discuss the branches, then people will be able to know about this relationship and the concept of matter and energy in a more good way. Now come to the branches of physics. Here you can see there are two main branches of physics: classical physics and modern physics. You see, in classical physics, which was developed before 19th century, and modern physics developed after 19th century. Classical physics includes 5 more branches: classical mechanics, waves, thermodynamics, electromagnetism, and optics. And modern physics includes further atomic physics, nuclear physics, and quantum mechanics. These are some of the major branches of physics which you people will discuss we people will discuss in this session. First of all, come to the classical mechanics. We will now, one by one, we will go into the detail. Classical mechanics. Classical mechanics is the study of effects produced by a force. This is basically the branch of physics which you can say mechanics. It's mechanics. Mechanics is a branch of physics or classical mechanics. It is the study of motion of objects basically. It is the study of the causes of motion. It is the study of the effects of motion. Like if you want to study the motion of a car and the effect of the high speed, of its high speed, all this knowledge will be in mechanics. If you want to study the working of hydraulic machines, this will also be a part of mechanics, and this mechanics is a part of physics. Now come to the waves. Waves is the study of effects produced by a vibration or an oscillation. Vibration and oscillation. This is basically a study of a sound. It deals with the physical aspect of sound waves. The production of sound waves. In this we study about the properties and applications of sound. Like oscillation of pendulum, these are some of the examples, some of the applications which we discuss in this branch. Sound produced by a violin, how they produced, what are the properties of the vibrations which produced in this, and what is the purpose of the production of this sound by a violin. Then the noise produced by a fighter jet, how it produced, what are the effects of the production of the noise of this fighter jet, what will be the effects, how it will be reduced, how it will be increased. All these things we will discuss in waves, which is relevant to sound, which is relevant to vibrations, which is relevant to the oscillations. Now come to the next branch, that is thermodynamics. It is totally deals with heat. Keep this thing in your mind that it is totally deal with heat. This branch is totally deals with heat. In this we discuss about the effects produced by a heat. In this we will discuss about the nature of heat. In this we will discuss about the modes of transfer of heat. So this is what thermodynamics is. All the applications which are relevant to, which are related to heat, we will discuss in thermodynamics. Like why engine produced heat, how a refrigerator works, expansion of mercury in a thermometer, this is due to heat energy. So all the relevant things, applications, properties of heat, all stuff which is relevant to heat we will discuss in thermodynamics. In electromagnetism, we discuss about the effects produced by a charge or a magnet. In this we will discuss the relationship between electronics and magnetism. Electricity, electric charge and magnetism. We will discuss the relationship between it. Both have effects on each other, both have a strong relationship with each other. And this we discussed about the charge at rest or in motion. We discussed about the effects of the charge which are at rest, the charges which are moving, and the relationship with magnetism, generation of electricity, working of a heater, light thundering, all these phenomena we will discuss in electromagnetism. Optics totally deal with light or the instruments which work upon the basis of light. Like mirror, we can see our image in a mirror with the help of a light. The colors of a sky, this is all due to light effect. The colors seen in soap bubbles, all this is due to light effects. The rainbow we see, due to light. So effects produced by the light, the application of light or optics, the instruments in which light is involved, like you can say telescope, microscope, your glasses. Fine, all these optical instruments, the use of optical instruments, the aspects of light, the properties of working of optical instruments, all this stuff is included in optics. Now come to atomic physics, very important branch of physics. In atomic physics, it is the study of structure of an atom and characteristics of subatomic particles. Now, in the start, I told you people that physics is the basis of many sciences. Here you can see that the structure of atom, the characteristics of subatomic particles. We can see a lot of books and material about such topics in chemistry. So this information gives you the basis for chemistry. So physics, you can say, is the mother of many other sciences. Anyhow, atomic physics is the study of structure of an atom and characteristics of subatomic particles, like neon signboards, application of this branch, working of a laser, working of compact fluorescent light, and all that stuff. Nuclear physics is the study of atomic nuclei, their constituent particles. Atomic nuclei means the nucleus of an atom. So in this, we basically discuss the nucleus of an atom. The subatomic particles which are present in the nucleus, we will discuss those atomic particles. Like how nuclear power generates, what is carbon dating, what is radiotherapy, how it works, the process of fission and fusion in nuclear bombs. All this stuff and phenomena are included in our nuclear physics, and this is a part of nuclear physics. Now come to quantum physics, quantum mechanics, sorry. Quantum mechanics is basically the behavior of matter and energy at atomic scale. Atom is basically the smallest and the tiniest particle of an element. So at atomic scale, at very lower level, we will discuss the behavior of matter and energy in this quantum physics. Here you can see smartphones, electron microscope, magnetic resonance imaging, all these applications are based upon quantum physics. Well, you see, this is all about the branches and the introduction of physics. Now come to the last topic, that is physical quantities. First thing and very basic definition of physical quantities is that all measurable quantities will be called as physical quantities. For example, you can measure length, so length is a physical quantity. We can measure time, so time is a physical quantity. We can measure distance, so distance is a physical quantity. We can measure volume, so volume is a physical quantity. We can measure temperature, so temperature is a physical quantity. So all measurable quantities will be called as physical quantity. But we cannot measure aggression, we cannot measure happiness, we cannot measure sorrowness. So all these will not be our physical quantities. Keep this thing in your mind. All measurable quantities will be called as physical quantities. There are two main characteristics of physical quantities. Number one, numeric magnitude, this one, and number two, SI unit. Here SI stands for System International. I am repeating, SI stands for System International, or you can say International System of Unit. It is all over the world, it is standardized. So two basic characteristics of measurable quantities, numeric magnitude and SI unit. Let's suppose the height of a child is 104 centimeter. So here 104 is a numeric magnitude, numeric value. You can say the numeric power. Fine. And along with 104, you can see cm, that is centimeters. It is System International Unit, SI unit. So if you see, if you just write this 104, this is just a numeric magnitude. If you will not write this centimeter, you will not be able to check that about which quantity we are talking. If you just put or write 104, just write 104 here, then you people will not be able to check about which we are talking about. But if you write centimeters about it along with 104, then you people will be able to add this 104 is basically the length or the height of a child. If you people write just seconds instead of centimeters, then you people will be able to say that this S is basically second. So 104 seconds means we are talking about time. Okay. If you write about, if you want to write about, let's suppose, mass, if I write 5, just 5, this is just a numeric magnitude. But if I write kg along 5, this means I am talking about mass. So both things are very important, this numeric magnitude and this SI unit. So both are characteristics of any physical quantity. Now come to the types of physical quantities. There are two main types of physical quantities. Number one, base quantities. Number two, derived quantities. The quantities on the basis of which other quantities are expressed are called base quantities, and the quantities that are expressed in terms of base quantities are called derived quantities. This means these derived quantities are dependent upon base quantities. This means these derived quantities are formed with the help of base quantities. When you people will add two or more, divide or multiply two or more base quantities, then you can get a derived quantity. First of all, what are the main base quantities? Students, there are just 7 base quantities over which derived quantities are dependent: length, time, mass, temperature, electric current, luminous intensity, or you can say intensity of light, and amount of substance. These are 7 base quantities over which derived quantities are dependent. By using these 7 base quantities, you people can make a new quantity. That quantity will be called as derived quantity. Let's suppose if you want to talk about area, the formula for area is length multiplied by width. Width is basically also a length. So by multiplying two lengths, you people will be able to find the area. So lengths, here two base quantities we people are using, length and width. Width is also a length, so length is used for deriving this derived quantity, that is area. If you talk about velocity, here you can see velocity is equals to distance divided by time. Distance divided by time. So here you can see distance is a length, time is a, you can say, a base quantity. Distance is a length, so length is also a base quantity. By dividing two base quantities, you people will be able to get velocity, and velocity, that is why it's called derived quantity. That is why in this definition you people can see that quantities that are expressed in terms of base quantities, means base quantities form derived quantities. That's all from my side in this session. I hope you enjoyed this session, and it will be a very informative for you people. And the students who are learning in class 9 in Pakistan, if they will see from the book, after listening this session, then it will become very helpful for the students to learn their topics in a very fruitful way. Thank you so very much and have a good day.